Happy Monday. We are gonna hit May on Friday. It's gonna be May 1 on Friday. I really can't believe that. And that really means that we've been going for 6 weeks with distance learning. 3 weeks before spring break and 3 weeks after spring break. By the end of this week, at least. Quite insane. So what we're gonna do today is a quick review of what we've done so far, and then an introduction to what we're going to do today. So first, you'll see that we've got the first and second quadratics, and in these cases, these are called incomplete quadratics because we're missing a term here. So in our first one, we've got 2x squared minus 8. What's missing... Actually, I'm going to write that at the bottom. What's missing is, in this case, the bx. And for the second one, what's missing is the c term. Now, when you're dealing with an incomplete quadratic, there are specific strategies, or I guess you could say a specific method that you need to use in order to solve a quadratic. And when I say solve, I mean find the x-intercepts of it, such that when I plug a number back into my equation, it spits out 0 as my output. So I'm trying to find an x value such that I input it into my function and it spits out 0 in response. That's how you know you solved a quadratic, or any equation when it's set equal to 0. So for the first one, by far I'd say the easiest, because it's just like you're solving a linear function. You just got to remember to square root it at the end. So with a when you have a linear function, you move the constant to the right side of the equation. So I'm adding 8 to both sides. That cancels it on the left side, and we're left with 2x squared equals 8. Now what do I do, right? I'm trying to isolate the x, which doesn't look like an x, now it is. I need to divide both sides by 2, and I'm left with x squared equals 4, because 8 divided by 2 is 4. And now, last but not least, this is where you got to remember to square root, because I want x by itself, not x squared. So if I take the square root of both sides, I'm left with x equals the square root of 4, which we know is 2. But what I need you guys to remember is that this is, when you take the square root of a number, you are essentially having two answers possible. So this is going to be plus and minus 2, because 2 squared is equal to 4, but negative 2 squared also equals 4. So in both those cases, we get 4. So if I'm trying to take the square root of 4, I don't just have one answer. I'm going to have two possible solutions here. So x equals plus or minus 2. Or if you wanted to write it out, x equals positive 2 and x equals negative 2. Most commonly, you're going to have two solutions for a quadratic because of the way that the parabola looks, right? The parabola's got an arm to the left and an arm to the right. And so those arms are going to cross the x-axis at two spots. So you're going to have two x-intercepts. Therefore, we're going to have two solutions. All right, let's look at the middle problem. In this case, this is missing the c term, which requires us to do factoring, where we are going to factor out the greatest common number between 4 and 16, and then we're going to factor out the greatest common variable between x squared and x. So first, what's common between 4 and 16? What's the greatest common factor between those two numbers? I'll give you a second to think about it. Okay, second's over. Let's move on and figure out, okay, 4 and 16, well, they're both divisible by 1, obviously. They're both divisible by 2. Neither of them are divisible by 3. They're both divisible by 4. And we can't go any higher than the smallest number. So 4 is our greatest common number. And now, between x squared and x, Well, the greatest common variable is x in this case. I can't go any higher than that because x squared is not here. If I had a squared there, then sure, but that's not the case. So the greatest common variable is x. And then that leaves us with whatever is left over to go inside the parentheses. So when I'm looking at 4x squared, if I divide 4x squared by 4x, the 4's cancel out, and x squared divided by x leaves me with, well, one of the x's is going to cancel out, and so I'm left with a single x. And then when I do 16x divided by 4x, well, first, 16 divided by 4 is positive 4. X divided by x cancels each other out. So that leaves me with 4x times x plus 4. Now again, this is equal to 0, so I'm trying to solve for 0. What we know is that if I can make this equal to 0, and if I can make this equal to 0, since this is multiplication, anything multiplied by 0 is going to equal 0. So, moving on, I'm going to set each of these equal to 0. So 4x equals 0. Divide both sides by 4, and I get x equals 0 as one of my solutions. And now I'm going to take this one to the side. X plus 4 equals 0. Subtract 4 from both sides, and I'm left with x equals negative 4 as my solution. Two solutions, because my parabola has going to the left and going to the right. Now that's not always the case, but the way that I've designed these, you will be seeing a lot of two-solution problems. So from here, we get to the final slot. X squared plus 10x plus 25. We've got our ax squared, we've got bx, and we've got c, all equal to 0. Now when you've got a complete quadratic, if you remember, I want you to use the quadratic formula. X equals the opposite of b divided by 2a plus or minus the square root of 4, of b squared minus 4ac divided by 2a. Now, the rest is history. That's for you to decide. But what I'm telling you is there is a new way that we could actually factor, or we could actually solve this quadratic that's going to be way more efficient, way faster than using the quadratic formula. So let's go there. We're going to take this one and we're going to go to the next page. So we've got x squared plus 10x plus 25, and that is equal to 0. First, we want to factor this. So number one, factoring. If I'm going to factor this, I don't need the equals 0 yet. I'm just going to factor this. What I want to find is which two numbers, and this is where playing the X game on Delta Math will come in handy. Which two numbers, here are your two guidelines. What are your two numbers, right? I'm going to try to find two numbers such that the two numbers multiply to C, but they combine to B. So multiply to C and combine to B. What do I mean by that? Well, 25, that's C, and 10 is our B, right? In our standard form, ax squared plus bx plus c, right? We've got b and c. So we're looking at 25 and 10. So this is where the X game on Delta is going to practice this same pattern. What two numbers multiply to 25 but add to 10? And so I'm going to actually draw, something for the X game, right? I'm going to draw that out here. So what multiplies to 25, but when you add them together you get 10? What are the two numbers? So I need to plug them in here. Now, you may notice that these are both multiples of 5. So 25 is divisible by 5, and 10 is divisible by 5. So we could use that for sure. 5 times what gives me 25? Let's start there. 5 times 5 gives me 25. So 5 times 5 equals 25. Check. What if we add them together? Does 5 plus 5 equal 10? Question mark. And in this case, it sure does. So that means that our two numbers are 5 and 5. What in the heck does that even mean, though, Dealman? You might be wondering that. Okay, so we're playing the X game. How is that going to help us? Well, when you are trying to factor this, well, in factored, once you've factored it, it's going to look like something in parentheses times something in parentheses. Well, I'm first going to have x and x, but what numbers go here? And how do I know that those are pluses? I don't know that they're pluses. Well, the number 5 and 5 are what we decided, so it's x plus 5 and x plus 5. Perfect, right? So I factored this. Now, how do I know that I factored this correctly? And also, why do I use the word factoring here, but I also use the word factoring for this one? Well, the process of factoring is I'm rewriting a quadratic expression as a product of factors, right? When you have two numbers multiplied by each other, they are called individually factors. So 5 times 5 equals 25. The 5 and the 5 are factors. In this case, I'm doing x plus 5 times x plus 5. Those are called factors. Now, how can I check to make sure I did this right? Well, we've got x plus 5 times x plus 5. Does this look familiar to anybody? Do we remember, if I were to try to put this back into this form, x squared plus 10x plus 25, what is this called? Starts with an E, ends with a G, and it would be called expanding. How do I expand this product of linear factors, right? There's a linear function in here, and there's a linear function in here. How do I expand those to make it into a quadratic again? Well, remember FOIL, first, outer, inner, last. So I multiply first, then outer, then inner, and then last. So if I multiply first together, I'm getting x times x, which is x squared. Then if I do last, it's going to be x times 5, so that's a 5x. And then if I do inner, well, 5 times x, so another 5x. And then if I do last, 5 and 5, that is 5 times 25, that's 25. Now I need to combine like terms, and that's going to equal x squared plus 10x plus 25. Is that the same thing as what we started with? Answer is, oh yeah, most definitely. So that means that I have successfully factored it here. I did that right. So the way you can check factoring is by expanding it back into the original quadratic. Factoring and expanding in this form are the opposites of each other. Just like when we did this on the first page, if I factored this into 4x times x plus 4, if I were to try to go back and put it back into the original form, I would have to distribute the 4x to the x and the 4x to the 4, and that would give me back my original. Sorry, I have a lot of scribbles now. This type of factoring, when you have a complete quadratic, can be checked or undone by expanding. But now, I've got this x plus 5 and x plus 5. Now, if I'm trying to solve a quadratic, what do I go and do with that? Well, x plus 5 plus x plus 5. In this case, you've got x plus 5 times x plus 5, and we're trying to say, when does it equal 0? What values of x do I need to make this equal to 0? And complete 0. What I like to do is split it up, because you need to set each of these equal to 0. Now, I oftentimes will use arrows, but I think one way that has been found to be really nice is make a column. Two separate columns, kind of divided up and into two different problems now. So x plus 5 equals 0 and x plus 5 equals 0. I need to solve for x. So that means I need to isolate the x. In this case, it's just by subtracting 5 from both sides. So I get x equals -5. And over here, I'm going to subtract 5 from both sides as well, because they're canceling out. And I'm left with x equals -5. So really, my solution as a whole is x equals -5. In this case, I only have one solution because, well, these are identical to each other. And on a graph, what this would look like is, well, x equals -5. Let's say that -5 is right here. It's going to look like that. That was a really poorly drawn quadratic. I need to give you guys a redo. Let's say that this is -5. There's one arm. There's the other. And it, believe it or not, did indeed cross the x-axis right at that one point, right here. Right at that point. Make it distinct. There we go. So that is factoring a complete quadratic. I'll show you one more example in full swing. So we have x squared minus 13x plus 40. So, if I play the x game, what two numbers multiply to 40, but when you add them together you get -13? So now you got to think about, well, we got a positive and a negative here. So, well, I've got 40 and I've got -13. What are some factors of 40 that could potentially give me an odd number? Well, factors of 40 are, well, 1 and 40, 2 and 20, 3 and, well, it doesn't work with 3, 4 and 10, my bad, 5 and 8. And that is, I believe, it. So, which of these two numbers could I add together, combine together, in order to give me -13? Well, 1 and 40 definitely will not work, because there's no way that I could add or subtract those guys together to give me -13. Now, with 2 and 20, that's not going to work either, because if I did 2 minus 20, that equals -18, or if I did 20 minus 2, that equals +18. Neither of those are a -13, so that won't work. 4 and 10, well, 4 minus 10 equals -6. 10 minus 4 gives me +6. Or if I just add them together, 10 plus 4 equals 14. Close. And then -10 minus 4 equals -14. So that was the closest we've gotten, but it isn't 13. It's not -13, so that's not going to work. So let's try 5 and 8. Well, 5 plus 8 equals 13. 5 minus 8 equals -3. 8 minus 5 equals +3. Is there one combination that I haven't done yet that could potentially give me a -13? And you should be screaming, yes, yes, yes. In this case, it would be a -5 minus negative 8 gives me negative 13. So a negative 5 and a negative 8. Negative 5 and negative 8. Those are my two numbers, because think about it, negative 5 times negative 8, negative times a negative becomes a positive, so I get 40. Negative 5 and combined it with negative 8 gives me a negative 13. So that is absolutely golden. We are set for lift up to continue on with our equation, with our solving. So this is equal to 0 and we're trying to solve it. So we factored it into a x minus 5 and x minus 8. So x minus 5, right, because I chose negative 5, and that's going to be multiplied by x minus 8 because I did negative 8. That equals 0. Anybody that remembers where we should go next should say I'm dividing it into a column, right? X minus 5 equals 0, and then x minus 8 equals 0. And I need to solve these individually for x. In this case, add 5 to both sides, and I'm left with x equals positive 5 as a solution. And over here, I need to add 8 to both sides, and I'm left with x equals positive 8. Now, how does this look in a graph? Those are my two solutions, x equals 5 and x equals 8. On a graph, just a sketch, if I've got x equals 5 and x equals 8, let's say that this is 5 and this is 8. My graph is going to look something like that. Now this arm is going to eventually cross at the y-axis at the y-intercept of 40, but anyways, that's beyond the point at this point. We really just care about the x equals the 5 and the 8 at this point. And that is that. Now, I strongly encourage you, if you have questions, to watch the video on delta, because I'm going to have you guys practice a teeny tiny bit of these today, and then I'm going to have you guys practice a teeny tiny bit, or a lot more tomorrow. Might change my mind about practice for today. When you do the assignment, you might or will probably see what I've decided. But for now, you will be trying to do 2 factoring, 2 of them where you solve, and then you'll be doing the X game a couple of times. So this video is about 23 minutes, so that means that you've got officially 22 minutes to work on that delta to give you your maximum time of 45 minutes for the day. This is going to be a little bit heavier of an assignment because there is a lesson involved before the delta, but that is a-okay. You can all handle it. You're doing an amazing job, and here we are, breezing into May on Friday. Before this gets any longer, I'm going to sign off now. Thank you guys for your attention. Make sure that you have taken notes like I instructed you. Not in the video, but on the Google Doc, I told you to take notes. And refer back to this video, rewind it, pause it, fast forward, whatever you got to do to see the parts that you need the most. Thank you guys. Miss you all. And I will talk to you on the Google Doc.